Okay, so number 9. Let's do the first one. All variables are stored in the global scope of your program. Is that true or false? That's false. Okay, only the variables that you write on the outermost indentation level will be considered global. Everything else, if it's inside of a function, will be considered local to the function. Okay? When a mutable thing is passed to a function, it is possible for changes to that thing to persist after the function is finished executing. Yep, that's true. As we've seen a lot in class, anytime you give something like a list or a dictionary to a function, you're able to change that thing inside the function such that that change persists outside of that function being done. So how many arguments are provided to each call? Well, if we zoom in here, we'll see that the print function on the first line starts at this parenthesis and stops at this parenthesis. So the commas that don't appear inside of other brackets, like a list square bracket, will be the things that separate the arguments in this print call. So that means that we have 1 argument, 2 arguments, and then 3 arguments. So there's 3 total for this one. For the second one, print list range 052. Well, everything in this paren and then this paren will be the arguments to the print function. So notice there's no other commas that appear not outside of other functions or other brackets. So that means there's really only 1 argument to this function, and that's this call to list that transforms this range into a list. So there's only 1. So which function is called first when evaluating this expression? Okay, so this expression, what we're going to do is figure out the calls. So let's do it. So this is the open curly brace for the what's it called? For the x function. So that means let's find where this x function is done executing. So another left paren, another left paren. So we've got 2 more right parens to find before we're done with the argument to the x function. So we've got a right paren, like that's 1. So let's see if we can find them. There it is. So we've closed the call to y, and now that means this right paren is the last thing for the x function. That means that this entire, means everything in here is the argument to the x function. And so the a function is similar. It's everything that's going to be passes an argument to the a function. So the question here is, what call actually happens first? Okay, so notice how we are adding the results of these 2 function calls together. So because we're adding, I have to do the stuff on the left-hand side of the addition first. It's just how our order of operations is going to go. So that means figuring out what this, which of these function calls happens first. Well, it can't be x, because there's still this expression inside of x that has to get figured out. So we should go in and figure out what happens in here. So we've got the number 4, that's fine. Then we have this call to y that gets added into 4. So the same reasoning applies here. We don't actually call y until we know for a fact exactly what we're passing it. So we go inside of y and find we're passing it this, okay, z5 to the power of 2. Well, this is the argument to the z function. There's nothing more that has to be reduced about this argument. And so that means that this function can now be called in order to figure out the rest of this expression. So it is, in fact, the function z that will get called first. Z. So which of the following function signatures are not allowed? Select all that apply. So which ones don't work? So the ones that don't work, def function, a equals b equals c equals 0. This doesn't work. Okay, this is bad. Okay, why doesn't this work? Well, these values, or default values for a and b, don't exist yet. Right? In the function signature, we don't know what b and c are. What about number b? So def func a, and then b equals 0, and then c. So remember the rule, you have to put the default parameters after all the positionals. So this one won't work. Def func abc, c equals 0. So the ordering on this one's right. We've got all of our positional parameters before our default. But the one big problem is we can't double dip. You can't have C as a positional and C as a default. You have to pick exactly one. So this one won't work either. So let's see, def func, so DC, positional parameters, that works. A default set to some value, that one's good. Cool. So the only one that works is D, the rest of them will fail. So now we look at number 6. We've got a function, and in the global scope of this function, we begin executing our code. So we've got x equals 0, 1, 2, 3. So we're going to draw out the memory here. X is a reference to a list. So we've got the list. It's got 1, 2, it's got 0, 1, 2, and 3 in it. And X is going to store a reference to this list. When I call this function, okay, the first thing that we do is we print mystery x. So we're printing the return value of this function. So let's go and compute mystery x. So this function, right, will generate a scope only for this mystery function. We take this mystery function, we give it a data variable. Okay, what is this data variable? It gets the value of the argument. The argument is x. X is just a reference, and so this data variable is the same reference. So note that we're crossing the boundary here. Right? We're inside the scope for mystery, but the variable data points to something that's outside of this scope. And pay close attention, because that means we're going to be able to change stuff from this function. What exactly are we going to change? So the first line says data.append 20. This says follow the reference and append the number 20 to that list. So we're going to take this list and we're going to add in the number 20 on the end. Cool. Now data equals 30, 40. When I do an assignment, it means I break the alias. Okay, so the alias is broken. We're no longer pointing to the list that existed outside of this scope. Instead, we generate a brand new list within scope that has the numbers 30 and 40 in it. And data is now a reference to this list. So then when the next line of code is data at 0 equals 50, follow the reference, you go to index 0, and you change that number to 50. Return data says return the list that we just made. So return 50, 40 out of this function and print it out. So we're going to print 50, 40, because that's the return value of this function. And next to it, we print the value of x. The value of x is the list 0, 1, 2, 3, 20. And that's what gets printed. Okay, So for this one, we're going to write a function called shift. It accepts a list of integers. So some list of integers, x's, and another integer, x. It will shift the contents of the list, x's, to the left by this integer x, filling in the right-hand side with zeros. And you can assume that x is going to be positive, not negative. The list modification happens in place, so we shouldn't return anything. Instead, we should be modifying x to our x's to our liking. So this gets modified. So how do I take this list and shift it over by 2? So 1, 2, 3, 4, 5. What I want is, as I'm traversing through this list, I should look to see if, hey, is there a number at the location dictated by where I currently am plus this shift value. Okay, so if there's a number at that place, that means this current spot should change to this number. And the other, if there is no number in that space, then this current spot should change to a 0. And effectively, what that's going to do is, should there be a corresponding value, just take that value and copy it into this location. If there's not a corresponding value, just set yourself to 0, because that will do the same, have the same effect as shifting. So what we're going to do is loop. So let's write for I in range length of x's. So I'm going to start at the very beginning index of this list and test. So hey, if this I, this position, plus this shift, is this a valid index in the list? Right? So is it less than the length of this list x's? If it is, that means the number in this location should become the number at position I. So let's write that. Then let's take x's at position I and update it, or shift down the thing at this position I plus x. X's at I plus x. Okay. If, on the other hand, we find that by attempting this shift, we are bigger than or equal to the length of x's, and that's a bad index. That means we're now so far down this list that there's nothing to shift into this location, and instead I should be updating this position in the list to be a 0. And so if I were to run through this using the list 1, 2, trying to list 1, 2, 3, 4, 5. Okay, if I start with a value of I as 0 and an x value of 2, like in the example, 0 plus 2 is index 2. Index 2 is less than the length of this list, so 2 is less than 5. So what we're going to do is take the thing in index 2 and put it in index 0. So we're going to copy that information. Index 0 is now the number 3. Okay, so the next value of I is 1. 1 plus 2 is 3. The thing in index 3 is this. So this number 4 takes the spot of the thing in index I, index 1. So at 2, it turns into a 4. And now we're going to be in a situation where I is equal to 2. So we are looking at index 2 plus 2, or index 4. 1, 2, 3, 4. So the thing at index 4 is the number 5. Number 5 takes over the thing at index 2. So index 2 is this number 3, meaning that 5 gets put in there. So our next value of I is 3. And 3 plus 2 is 5. There is no index 5 here. So we're in this else clause where we set x is at index I equal to 0. So x is at index 3 becomes 0. And then we move to the final value of I, 4. 4 plus 2 is 6. 6 is bigger than the length of this list. So we go to index 4 and we overwrite that with a 0. And so we get our right answer here. This also works when the shift is bigger than the length of the list. Right, so when I have this example 1, 2, 3 and I shift by 5, the value of x is 5. When I start, I is 0. 0 plus 5 is 5. 5 is bigger than or equal to the length of this list, and so we go to index 0 and we replace it with a 0. And the same thing will happen for each of these other indices. Right, all these things will just get replaced with zeros. So nice, this works.